So, my name is Freddie Örnebjär. I live in Stockholm, work for Brocade. I just wanted to take a minute or two to talk about a bit about Brocade because a lot of people don't know so much about Brocade. We are the market leader within SAN storage. We have around 75%, depending how you count it. We have a lot of OEM vendors from the SAN side. We work with HP, we work with Dell, we work with IBM. On the IP side, we think we have a fairly competent campus portfolio. We have our own fabric solution. We base our fabric solution on Trill, open standards, because we believe that open standards is the way to go. We don't really have a scalable problem with MAC address in that sense of view. We are also very present at service providers and internet exchange points. For example, here in Finland we have Physics as a customer. In Sweden we have NetNode. And then in Amsterdam we have M6 as a customer running 100 gig on our cards. So that's around what we see and what we do on the market today. And now I've been tasked to sort of talk about software-defined networking and OpenFlow. And I think when you talk about software-defined networking and OpenFlow, everyone has their own opinion what's going to happen and how this is going to pan out. Cisco has their own opinion, we have probably our own opinion, and when it comes down to individual persons, they have their own opinion how software-defined networking is going to work out in the future. I don't think we're really there with software-defined networking yet, so you can start to implement it on a large scale. We have a US-based project with Internet 2, who's actually doing it right now, which I think is going to be one of the first OpenFlow networks. But if you look from a sort of enterprise point of view, exchange point of view, carrier point of view, we're probably not really there yet with software-defined networking. I think we're coming there from a Brocade point of view. I think it's going to make sense around March next year to start to implement OpenFlow. It also comes down a lot to the controllers in OpenFlow and how they're actually going to pan out and how they are going to, which versions they're going to support. So, what is software-defined networking? Or what does software-defined networking do for you? Well, basically, it decouples the control plane from the switch. So it removes the intelligence from the switch and brings it out to a software-defined networking controller box, which can be from any vendor. We don't manufacture control boxes. There are a couple of one. Flowation, which does open source one. Big Switch Networks. And NIC has one. And that's really where the intelligence in software-defined networking lies. That you have an external controller looking at the flows from the network and decides what do I do with the traffic. Software-defined networking itself is an API, which you sort of write into or you enable from our boxes, and the controllers actually talk to the API. So. Yeah. So basically what we do is we take the control plane and then we move it out. That was software-defined networking does in a fundamental way. When you look at SDN, which are sort of OpenFlow is one part of SDN. Then you have a couple of cloud APIs, OpenStack, VMware, have one, Microsoft Cloud Stack. You have protocols like VXLAN from VMware, which helps you to connect data center in between each other. Microsoft just rolled out their one, NVGRE, same thing. Then you have traditional things like MPLS. Every one of these protocols sort of have one purpose, and that's to transport data somewhere. But I think it's fairly important to remember that when you talk about SDN and OpenFlow, SDN is not only about OpenFlow. SDN is actually the entire concept of this. It doesn't come down to just OpenFlow as a product or a protocol. So who's behind this sort of idea and concept? It's sort of important also to understand that the networking vendors wasn't the one that actually drove this. The founding members from OpenFlow came from operators, companies like Microsoft, Facebook, Google, who has their own OpenFlow implementation, as I think, completely own, Yahoo. Since then, I mean, around 70 major companies have joined when they sort of launched this OpenFlow public. There's been recent interest from the IETF. So, because to understand, I mean, OpenFlow is not a standardized IETF protocol or anything. OpenFlow came from the companies because they wanted to achieve things in their network. They wanted to achieve a better routing solution. They wanted to achieve better utilization of links and things like this. So there wasn't really a standardized protocol that came out. What IETF, I think, is right now looking at this, if they could do some sort of standard around OpenFlow. So that's where we are, and that's where sort of what's happening around OpenFlow. It's governed by something called Open Networking Foundation at the moment. Yeah. So OpenFlow protocol that enables communication between OpenFlow controller from router. Control plane decisions are made on a flow. So you look into a stream or a flow and see that this flow is going to go from point A to point B. What's the most optimal path of doing this? Can I go a better switching path than traditional ways? So what OSPF are doing, can I go a better path? It's important to understand that OpenFlow also doesn't use OSPF in that way. When you use OpenFlow, you use the entire way. You don't have any routing protocols embedded into OpenFlow from that point of view, only in traditional routing protocols.
So, can I ask a question?
Yeah.
So does it mean that you change the packet switching to flow switching, or should I see that?
Yeah. So, yeah. So that's a fundamental way if you do OpenFlow.
So you're building circuits?
Yeah. In a way. When you communicate, the router and the controller communicates to our OpenFlow protocol. It's a defined protocol which you use to sort of talk to the APIs. So as you said, talked about also a core question, the router actually maintains a flow table. So it maintains sort of where to send the flows. And the controller actually sort of tell the control plane in the switch to what to do. So, a bit more into detail what you can do. This is based out of OpenFlow 1.0. Brocade today supports OpenFlow version 1.3. There are currently no controllers on the market that supports version 1.3, which makes some things implementing OpenFlow a bit complicated, because in 1.0 you don't have IPv6. You're missing a lot of header things that you would like to use. So basically, if you want to do OpenFlow with IPv6, for example, you cannot do it today. That's sort of the message. You could do it in our boxes if you would try to find a controller that actually would support version 1.3, which we haven't found in the market. So, what can you do in OpenFlow version 1.0? Well, you can sort of go into a VLAN. You can add a VLAN to a flow. You can remove a VLAN from a flow. You can modify the tag. So you can say that I want this flow to have a tag 50 instead of 100 when it comes in. Or you can forward it to a port list. What's happening if this criteria doesn't match is that OpenFlow will drop the packet completely. So today OpenFlow has to match one of these criteria which you have on a green checkbox list. If it doesn't match, you will drop the packet. So it means that in a sense you need to sort of know what you're doing before you implement this. Otherwise it might lead to have a lot of problems. I talked with a customer to ours yesterday, and they want to do this. They didn't really understand at the moment that you have to do OpenFlow or not OpenFlow. So it becomes a problem from that point of view. What can you do? Well,
Okay.
yeah.
To that last thing, you have to do OpenFlow or non-OpenFlow use.
Yeah.
So, do I understand that you're saying if you apply OpenFlow to one of your routers, then every packet through that router has to be part of the flow?
Every packet to the port you enable OpenFlow on has to be part of that flow. So every part, when you do, I'll give you a better explanation. Well, if you enable OpenFlow on a port, you cannot run OSPF or anything on the port. You have to do OpenFlow. So that means if you say that port 1 is going to do OpenFlow, you can only do this. You can say that port 2 doesn't run OpenFlow and they can run traditional OSPF or IS or RIP or static routing on the port.
Good.
But you cannot, when you enable OpenFlow on a port, you have to run it. That's a traditional way, that's what most vendors are doing. Which also means that to have OpenFlow makes sense for you as a sort of company or IX or carrier. It doesn't really make sense to enable OpenFlow on one port. You have to do it throughout your entire network where you want to do the optimization. Yes?
How about connectivity between different data centers that are owned by different companies, for example?
Yeah.
Do they need some kind of policies between each other? Or how is the routing of the kind of things done with those things?
So,
can OpenFlow use it there? Or?
Yeah, so I will repeat the question to everyone if everyone didn't catch it. How about connectivity between data centers? Do you need to do any specific things? And if you're sort of doing different vendors, do you need to do anything in your type of controller? Well, so OpenFlow doesn't really define that type of standard at all. It's going to come down to the controller. I mean, you can do connectivity between data centers in OpenFlow to VXLAN. If we go back to this one. To VXLAN, for example, you can do through MPLS. You can do it through NVGRE. So what I'm saying now might not make sense in regards to the answer I did on your question, but you have to explain it soon. But so that, well, no, from that point of view, OpenFlow doesn't really care about if you could interconnect between sort of operators and anything like that. It's going to come down to what the controller allows you to do. If you want to interconnect between data centers, well, you need to have a layer 2 link or MPLS link, layer 3 or something between. So OpenFlow only cares about the definition of the flow, what's the optimized path of the flow. If you want to share between two operators, you need to have the controllers talking to each other, because otherwise you cannot define the path in OpenFlow. So that sort of might become a problem for you then. So it's very important when you think about implementing OpenFlow to actually do a review on the controllers at itself also. Because if you say that you take a proprietary controller from Cisco, it might not talk to any other controller on the market. And then you can do interconnects with any other operator. So you need to do an evaluation of what you want to do in OpenFlow and how you want to achieve it. From a switching point of view, we do an API. We provide an API that actually removes sort of intelligence. So from the switch itself. Yeah. So what OpenFlow itself, I mean, it doesn't sort of talk about any applications from that point of view. What it can do for you is it can create a more flexible network. For example, you can say that I know 4 o'clock, between 4 o'clock and 6 o'clock every day, I have very low utilization on one of my links. So we could define that, then we move a lot of traffic to that link. Or we can sell traffic on that particular link to customers of yours, saying that, well, you know, between 4 o'clock and 6 o'clock it's going to be cheaper for you to buy traffic because we don't have any utilization on this link. You can look at a latency of a link. And you can actually combine this together also. You can say, you can say that if you have a high latency, low traffic load, or high latency, high traffic load, we can reroute the traffic on a link. So it's very flexible in itself, what you can do in OpenFlow. It's your imagination that might set sort of the limitations here, and the controllers itself that's going to set limitations. But the concept is somewhere around that you should be able to save sort of your operational costs and spending on this. One key example is a customer that's actually precisely want to do. They say that between 9 o'clock and 12 o'clock in the night we have very low latency on our links for corporate customers. So it makes sense for them to look into the link then and say we're going to sell cheap traffic at that point of view.
It sounds like policy-based networking that we had like in the late 90s or so.
Yeah, but everything is all coming back and forward all the time.
Well, it feels miserably, I think,
Yeah.
but other than that.
But the thing is, you can also look at the latency of the link and say, we have a very high latency, maybe due to a bad SFP or something like this on this link now, so we're going to reroute traffic to another link. So to sort of ease down the traffic and maybe ease down on the load on that link. You can do sort of security-wise, you can say that we're going to drop certain type of flows because we don't like them. So if you want an orchestrated network, I would say this is ideal.
So it's like RSVP on steroids?
Yeah.
So then again, Brocade doesn't really believe that everything is going to be black and white. So we have sort of developed a technology which is Internet 2 is going to use when they start to implement OpenFlow, and that's called a hybrid port mode. So what we do is, even though OpenFlow actually decouples the control plane from the box, we maintain the control plane. So you can say, when you define that a port is a hybrid port in our world, you can go in and tell it that first you should look at the OpenFlow. So if we go back here. So first you should look at this one. If that doesn't match, we will go ahead and look into our routing table, or traditional routing table, OSPF routing, or MPLS routes, static routes, everything. BGP routes, for that example. So we sort of believe that you're going to have some type of intelligence, and this makes sense because when you start to implement OpenFlow today, if you don't have a hybrid port mode, you're going to have to either turn it on or turn it off. In a hybrid port mode, you can turn hybrid port on, you can build your OpenFlow network, and then you can define that this VLAN actually belongs to OpenFlow. And this VLAN actually belongs to normal, standard customers. And when you want to move that customer over to OpenFlow, you just define that in the box and say that this customer is now going to be on an OpenFlow-based VLAN. The way we do it also is that we can actually define if you want to have a sort of completely locked out way of doing this, that the customer is only looking at OpenFlow rules, or if you want to have a leak through, so you first look at OpenFlow rules and then you look at the routes, traditional routing. So what this allows you to do is sort of maybe to implement this in your network without tearing your entire network down during an entire weekend and tell your customers, well, now we're going to change. Because that's not really going to work in practice. It might look good in a PowerPoint when someone tells you this, but it's not going to work. So that's why we developed the hybrid port mode, which is available from us. The other scenario where OpenFlow makes sense is in a data center. And why it makes sense in a data center is because if you do vMotion from a server, you can actually optimize that path for the vMotion. You can optimize it so you say that now we're going to do vMotion, you get an optimal path to the network. Then you might get another path when it actually goes out to the internet. So you get an optimization in the data center. Combined with technologies like VXLAN, which we are, in our fabric, we're fully aware of VXLAN, so we can actually transport VXLAN between data centers and do a layer 2 network. Or more traditional MPLS, layer 2 networks. You can actually optimize the flow when you do things like vMotions and I don't know, backups, etc. in your data center. So that's going to help you probably a lot. And I think if you talk to the server guys, they're going to love this because that means sort of they don't really need to care anymore about which interface I'm going to put my vMotion on. I can just bring in a 10 gig interface or 40 gig interface in the server, and then your sort of path will be optimized depending on what you want to do in your virtual environment. So where are we going? Well, OpenFlow 1.3 is the latest version. I think 1.3.1 is coming out. OpenFlow 1.4 was actually planned, it's not released, it's delayed. Due to the reason that the OpenFlow Foundation wants to see more adoption in 1.3. As I said, today it's very inflexible because most controllers only support 1.0. So even if you see all these nice specs in 1.3, you cannot do it today. We from Brocade have a person actually on the member board of this, or the board of OpenFlow Foundation, who's working very hard to bring in OpenFlow or adaptation for 1.3. Most likely it's going to need more references to bring it out, more as a message. We are doing right now, said Internet 2, 100 gig links through the US. Hopefully that will sort of raise awareness a bit. But from a practical standpoint of view, for our IX or for a service provider, probably looking into like next year before this is starting to get serious. Some links, I think you get this sort of PDF, so you will have them. It's the Open Network Foundation, introduction to OpenFlow, and our OpenFlow page. We don't really talk that much about products in our OpenFlow, on our OpenFlow page, but we support OpenFlow in our core routers and in our fabric versions. So, I will be here till 5 o'clock when my flight when I have to drive back to Helsinki to get my flight to Stockholm. But if there is any questions after this, grab me. So I'll try to stay to the end of this session and then sort of run away if no one has any questions. And of course, if someone has any questions right now, so I think that's a no. And you have my email address also if you would like to sort of send questions. Yep, so that's it.
Thank you.
Thank you.